Okay. Hello everyone. Yesterday, as we all know, there was a launch of Chandrayaan-3, and approximately around 2:37, the rocket took off. And along with the rocket, the dreams and aspirations of 1.4 billion people also took off. Okay. It is considered to be a milestone for India, right? Why that is? There are different reasons for that. Okay. So I decided to make a video on that, starting from the very basics till the current scenario as to why India has actually gone for this. Okay, right. So let's start from the beginning. I'll not directly delve into Chandrayaan-3. First, we'll look into 1, then we'll look into 2, then finally we'll come to 3. Okay. Chandrayaan-1 took place in 2008. Okay. And the mission was very important at that point of time because it was the first interplanetary mission for India. Okay. And there were a lot of reasons why we chose the moon at that point of time. One obvious reason, because it's very close to us. Okay. From the Earth, the moon is approximately 3.8 lakh kilometers. Right. And there is one reason why we actually wanted to do that before that time. Okay. See, though we are saying it is a mission to the moon, there were a lot of things that were involved in there which were not outrightly spoken. Okay. Say for example, there is something called as Deep Space Network, DSN. Okay. As far as India is concerned, we'll call it as IDSN. Just 1 minute. Okay. Indian Deep Space Network. Okay. Just go by the name. Deep Space Network. Right. So the network which will be helpful for us for our deep space missions. So basically, what do you mean by deep space? Anything outside of the Earth is considered to be deep space. Okay. The farther we go, the deeper we are going into the free space actually. Okay. So what do you mean by deep space network is nothing but it's simple. From Earth, are we able to connect to the satellite we are sending there? Okay. Similarly, from Earth, are we able to manipulate the satellite we are sending there? Are we getting the data from the satellite? Are we able to receive the communications properly? Is there any issue with the communications? Okay. This is one network which takes care of things like that. Okay. So the first reason why we actually went for Chandrayaan-1 is this one. Because we wanted to test our deep space network. Okay. Your IDSN is present in near to Bangalore. There is a place called as Bailalu. It's a village. So in that one, we have the deep space network belonging to ISRO. Okay. Because like I said, moon is only 3.8 lakh kilometers from the Earth. Moon was obviously the first choice. Okay. And that network was also established in the same year before the mission of the moon started, 6 months before. Okay. First thing. Second thing, with the exploration to the moon, India has become one of the few countries in the world that actually did that. Okay, at that point of time. That was one more reason. Again, we were planning to become what we call as a soft power. Okay. Then along with that, we were also trying to understand our technological competence, as we call it. We had a launch vehicle. We were trying to see if the launch vehicle is efficient or not, if it is really capable or not. Turned out to be capable. Okay. So we were testing many systems also within that. That is also one reason why we went for moon mission. Okay. Then, after all of this, the obvious. We wanted to know more about the moon. We wanted to know about the surface. We wanted to know about the minerals. We wanted to know about the presence of water. Then we wanted to know about the atmosphere of the moon, etc. They are all usual. Okay. Right, this was the reason why we went for Chandrayaan-1. Chandrayaan-1 was supposed to be there for 1 year, but approximately after 9 months, 10 months, it got disconnected. Okay, but before that happened, in that one, we actually sent a small device which is called as Moon Impact Probe onto the surface of the moon in Chandrayaan-1. Okay, that particular device actually hit the surface of the moon, and just before the signal got lost, it sent some valuable data to the ISRO. And one of the most important findings at that point of time was, we were the ones who actually traced the presence of water on the moon surface. Okay, and the idea also, with the data we have got, the idea was also there that there is presence of water in the North Pole also, which is probably present in the form of ice. Okay, so if I am supposed to say what is the most important outcome of Chandrayaan-1, I will definitely go for finding out the presence of water on the moon. Okay, that information was important to even other countries also. It's not only a achievement from Indian perspective. Okay, right. Then after this we went for Chandrayaan-2, and Chandrayaan-2, the most important idea or the mission objective, it was to actually take a lander, put it on the surface of the moon, which did not happen with the first instance. Okay, Chandrayaan-1 was only an orbiter mission, it never landed on the moon. So we wanted Chandrayaan-2 to be the first mission that will take a lander onto the surface of the moon, which will have a rover inside that will be coming onto the surface again, and it will be collecting samples, analyzing the composition, etc., things like that. Okay, right. So we'll start with actually Chandrayaan-2. Chandrayaan-2, we know what happened, but before we come to that point, first let's look into some general terms. Okay, first one is soft landing. This is the one thing which I think we have heard a number of times here. Okay, so first let's talk about this one. Hard landing and soft landing, two types. Hard landing basically means crash landing. When you crash upon to something which is not controlled, which is not expected, or which is not planned, that will be called as a hard landing. But contrary to the hard landing, the term only is indicating it is soft landing. Okay, which means basically it is controlled landing, and before you land, the speed of the craft will have to be reduced to a great extent. Otherwise, you land with full force, which will again result in a hard landing. So you will have to control the speed parameters. Okay. Then finally, because you are going for a soft landing, the possibility of the satellite or the lander getting damaged will be very minimum. Okay, the one thing which we actually saw with Chandrayaan-2, because it was a hard landing, it became unresponsive completely. Of course, it was unresponsive a few kilometers away from the surface of the moon itself. But it crashed with such a speed that debris was found. Okay. So soft landing basically means you are landing under controlled parameters, then the speed is automatically reduced greatly, which will negate the impact on the damage of the satellite, of the lander, whatever you are trying to send in there. Okay. Right. Then there is one more thing here. Okay. The next important question that was asked during Chandrayaan-2. See, every country before they launch or before they take a mission onto the surface of the moon, the first thing they'll try to understand is where should we land it? What will be the atmospheric conditions in the area? Then what is the topography of the area? Okay. What will be the possibility that if we try to land something in that region, will either get crashed or will have obstacles moving forward, or because it's not present in a pleasantful area, it may have a problem navigating also. That is why the most important thing for these kind of missions is to find a healthy spot. Okay. Until now, whatever missions have been taken place by many different countries, as in this sense, three: US, USSR and China. These are the three countries which have done until now. Okay. They went just above the equator of the moon. Okay. Sorry. So, if this is the equator of the moon, most of the landings were found either north of the equator or south of the equator. They did not go too much higher or too much lower, either ways. Okay. But India has chosen the south pole of the moon. Okay. India will be the first country to have actually chosen that part, that region, to launch or land something in there. So the obvious question is, why South Pole was chosen that specifically? Okay. Right. The first one, challenging conditions. See, it is very well known fact that we see only one side of the moon. Because of the push and pull of the gravitational forces between the moon and the earth, we always see only one side of the moon, which results in a phenomenon what we call as tidal lock. That's the reason usually why tides are influenced by the moon's gravity. Okay. Anyway, because of this scenario, we always see only one side of the moon. The other side of the moon is commonly referred to as the dark side. And mind you, that dark side has never been exposed to the sunlight until now. Never. From the time of the formation of the moon for the last, let's say 4.2 or 4.3 billion years, that side of the moon has never seen the sunlight. Okay. So, if it did not see the sunlight, or if sunlight does not get exposed in there, the climatic conditions for that region will be very severe, to put it in a very simple manner. Okay. So, that is something which we have absolutely no idea about what we will be getting into there, because it has been untouched by anyone until now. That's the most important part. Okay. So, that is one of the reasons why we looked into it, because see, though the conditions are challenging, if we can actually succeed in those conditions, that will be a very big boost to our space program. Okay, so that is one of the reasons why other countries avoided it until now. That is one of the reasons why we projected to go forward with it. Okay, then possibility of water. I already said that area has never been exposed to sunlight. Chandrayaan-3 already proved that there is water present on moon surface. So, if this region has never been exposed to the sunlight, maybe water is still present in the form of ice. Okay, and not just liters. They actually believe there are millions and millions of gallons of water which is present in the form of ice on the other side of the moon. Okay, so the obvious question, why are we so why are we so insisting upon finding water? Okay, water is there, so what? Normally that question will pop. Okay, that will make more sense in another point. We'll come to that down the line. Okay, then frozen time capsule. This is one thing which is a little bit easier to understand. Okay, see, because the other side of the moon has never been exposed to the sunlight, it is safe to assume that the entire region might be frozen by solid ice throughout the surface. Okay, and you know very well that ice has a property of preserving something if it gets stored inside of it. You know, I think this you already know that we actually found some mummies and some animals that were frozen deep into the ice, maybe during the ice ages. Okay, and they were so well preserved that most of their physical features were still intact. Okay, so that's one property ice has. So if at all this region has been frozen solid for a very, very long time, whatever surface that is been there below it, that's all what we call as untouched surface. It has never been exposed, it has never been exploited. Okay, so that will give us a lot of answers regarding the origin of the universe. Okay, because those things have been formed at the very, very beginning, and from that time onwards, for this billions of years, they have not been touched at all. They may contain the initial stages of the formation of this one. Okay, because see, there is one popular theory that moon is actually part of the earth only. During the initial stages of formation of the earth, a huge meteorite hit the earth, out of which a huge chunk of it got separated from the earth. That chunk of rock only is what now we believe to be moon. Okay, so if that is true, then whatever was the composition and the formation of the earth in the beginning, the same holds true for the moon also. Because it is solidly frozen under, there is a very good possibility that all of that is original. Okay. Then terrain. Most of the terrain, what we know there is something which we don't actually know clearly also. Okay, so say for example, you are actually putting up a rover in one place and the rover starts moving, but all of a sudden the terrain is not plain. It's either mountainous or it's very deep, or there may be ravines in between, or there may be trenches in between. You never know what kind of topography the moon has to offer us. Okay, it is because of this ambiguity also they did not choose South Pole before. But now that we are technologically a little bit more advanced than we were, let's say in the last 10 or 15 years, we thought, okay, fine, why not try it. Okay. Then, untapped essential resources. It is believed that there are many resources that may be present in there. See, end of the day, that is also made up of rock. Rock will definitely contain mineral deposits. Okay, so they believe there is a lot of silver deposits, iron deposits. Okay, zinc, things like that. All of which they believe can actually be used in there itself. Why? Because down the line we want to make sure that moon is becoming what we say as habitable for humans. We basically want to send people to live on the moon. Maybe not all of them, at least maybe some of them. And why do I want to do that? Last purpose. Okay. Whenever you are planning any future missions which have to do with moving away from the earth. Now what do we do? The launch station will be present on the earth. From here, whichever country is trying to launch it, they'll be launching it from their own country. But what if you have a launch station on the moon? Then when you launch it from there, you will actually be saving that 3.8 lakh kilometers distance. Okay, so basically they want to make that as a future launch station. That possibility also has been examined by India. Not just India, many countries around the world are doing it. Okay, so these are the reasons why we have chosen the southern pole of the moon. Okay, right. Then, okay, this is what actually was supposed to happen during Chandrayaan-2. Right, the Vikram lander, it was supposed to be landing, soft landing, it goes like that. Okay, then from inside of it, there will be a rover that will be released out, and this rover will be moving around on the surface of the moon, collecting samples and analyzing them and sending the data back to ISRO. Okay, then ISRO will go for deeper analysis and try to understand what is actually happening there. Okay, so the problem came here only. The first stage itself was not successful. Because of that, the second stage got disrupted completely. Okay, and the worst part is we were only 7 kilometers away from the moon surface. At that altitude, suddenly the communications got lost, and the speed module which is supposed to control the descent of that particular lander, it got maybe corrupted or did not function properly, whatever may be the scenario. There was software glitches also present on that, because of which it could not actually go for a soft landing. Okay, so because of this step going wrong, everything else failed to follow up. Okay, right. Then, like I said before, we were trying to look into many things through the launch. Okay, the first one, the launch itself. Right, it was GSLV Mk3, which is considered to be the best heavy satellite launch vehicles we have. Okay, so this was in 2019. So at that time, cryogenic was still a new concept to India, operational wise. We have been working on cryogenic for almost 25 to 30 years now. Okay, so the first thing to test was the launch vehicle itself, GSLV Mk3. Okay, then insertion to the lunar orbit. This is always a very big challenge. See, putting a satellite around the Earth's orbit is far more relatively easier. I am still using the word relatively easier when compared to extraplanetary missions. Okay, but here the idea is that you should go for multiple maneuvers to put it from this orbit, put it onto the moon's orbit, then again from there slowly start bringing it closer to the moon surface. The intended orbit was 100 kilometers above the moon surface. Okay, so finally that Chandrayaan-2 was supposed to be 100 kilometers above the moon's surface. That was supposed to be the orbit. The orbiter is still there at that height, that altitude, taking a lot of pictures of the moon even now. Okay, then separation of the orbiter from the lander. This is again challenging. Orbiter will contain the lander inside. Once you are nearby the region where you are actually supposed to go for the descent or supposed to land, then they'll release the lander, then the lander is supposed to be coming down. This one also happened successfully. The lander did successfully detach from the orbiter. Okay, then this one, the orbiter itself. Orbiter was actually supposed to last for 1 year, but it is still there in the orbit, functional. Okay, so they wanted to see the functioning of the orbiter itself also, right? Along with all of this, this one, the lander, how is it actually landing? Were there any problems? Can we actually do that? And understand, after it is landed on the moon, let's say, if it is unable to release the rover onto the moon surface, all of this is again useless. Okay, so that is what makes lander important. And remember, lander actually has a communication network that can directly contact the Earth. You need not send the data from there to the orbiter, then the orbiter will send it back to the Earth. No, nothing like that. Vikram lander was given the capability to directly communicate with Earth. Okay, that is one more important thing they were trying to test in there. And finally, the rover, moving on the surface of the moon, trying to look into the obstacles, trying to still find its way out of it. Can we do that? Can they manipulate the movement of the rover sitting somewhere in Bangalore? All of these parameters were supposed to be tested using Chandrayaan-2. So like I said, contrary to the popular belief, it is not only about sending a mission to the moon. There were a lot of other things to be considered there. Okay, right. Then this is a comparison regarding Chandrayaan-2 and Chandrayaan-3. Okay, as I told you before, Chandrayaan-2 mission was not successful because just a few kilometers above the moon, everything got disconnected, and instead of landing on its legs, it crash landed, the debris was later discovered by NASA. Okay, right. So here, if you see, there are some main differences present in there. Okay, the first thing which does not change is that Chandrayaan-2 and 3, both of them have Vikram lander named after Vikram Sarabhai. Then Pragyan rover. Pragyan basically means wisdom in Sanskrit. Okay, so Chandrayaan-2 and 3 have the same components. The one thing that is missing in Chandrayaan-3 is the orbiter. Chandrayaan-2 had the orbiter, which is not being sent in Chandrayaan-3 because the Chandrayaan-2 orbiter is still orbiting the moon. So there was no necessity felt to again send one more orbiter around the moon. Okay, then instead of that, you have what you call as a propulsion module. So the propulsion module will be present inside in the orbit. That propulsion module is actually what will push the lander towards the moon. Propulsion, the name itself only is telling you. That will actually propel the lander towards the moon's surface from the orbit. Okay, right. Then the second thing, which is again common to both of them, is in both the cases, Chandrayaan-2 and 3, the lander and the rover, more specifically the rover, was supposed to be functioning for 14 days. Or to put it in technical term, 14 Earth days. 14 Earth days is basically what we calculate on the Earth, 14 into 24 hours. But for moon, you call it 1 lunar day. 1 lunar day is equal to 14 Earth days. Okay, so basically, to put it in a simple way, the mission was supposed to be going on for 14 days. Why? Because that will be the daytime. The other 14 will be night in on the moon. Nights are extremely very cold in there. The temperature will drop to minus 200 or minus 300 degrees also. So whatever equipment you have, will it be capable of working in that extreme conditions is again debatable. That is the reason why it is actually chosen for the first 14 days wherein the moon will be under the sunlight. Okay. Then the next one is the site. For Chandrayaan-2, the site was confined. It was a very small, diameter, where the landing was actually supposed to take place. But for Chandrayaan-3, they extended it. So 4 by 2.4 kilometers, which means 4 kilometers by 2.4 kilometers. That's a rectangular spread. Previously, it was very small, 400 by 400 meters. But now, as you can see, they have significantly increased or improved the landing area. Okay, so this is one more change you get to see there. Then the mission total number of days. Chandrayaan-2 was supposed to be in 48 days, which means that after 48 days from the launch, the lander will be on the moon. The lander was supposed to be on the moon. Chandrayaan-3, they have dropped it down to 42 days. So within 42 days, the landing will be taking place on the moon. So they are estimating somewhere around August 23rd or 24th, we will be able to make a descent onto the surface of the moon. Okay, right. Then apart from this, there were some changes made to the orbiter and some other parameters of the craft. Okay, the first thing is they actually gave the Vikram lander stronger legs now, so that in the event, even if it is hitting in a little bit hard, it will still be able to absorb the shock and stand instead of falling. Okay, see, if it is falling at, let's say, 500 kilometers per second, there is absolutely nothing now anyone can do there. Even if it is falling at 500 kilometers per hour also, that is still a very high speed. But ideally, the speed is supposed to be reduced somewhere around 10 meters per second, or let's say 10 kilometers per hour, something like that. Okay. So let's say if it instead of 10 kilometers per hour, it is landing at 20 or 25, the lander will still be able to withstand that shock. Okay. So the first change that has been made is this. They improved the strength of the legs of Vikram lander. The second thing, they gave it a larger fuel tank, which means now you can actually store more fuel inside the orbiter. Okay. And why do we need more fuel? Why do we need more fuel? Because if in case, see what happens is actually all of these mission parameters are very specific. If you don't put it on the right time, you may not get the required or the desired result. Okay, there is anyway a topic I'm taking about it, so don't worry about that right now. Okay, the idea is very simple. If you're not able to do it in one point, you'll have to again wait for some time before you can push it again onto the path. So if that is to happen, then it will be needing that extra fuel to move around. That is one of the reasons why that has been given this time. Okay. Right. So you have given it stronger legs, then you have given it more fuel just to make sure things are happening properly. Okay. Right. So these are the main differences between Chandrayaan-2 and 3. Please understand, Chandrayaan-3 is only primarily a follow-up to Chandrayaan-2. It's not a complete overhaul of the entire mission. We failed in the second attempt, we are trying it again in the third attempt. Nothing more than that. Okay. Right. There's a small video. This is what Chandrayaan-2 was supposed to do. The entire mission was actually supposed to be working out in this manner. Okay. It's a 3-minute video, so you just bear with me. Liftoff start in T-10 seconds. 10, 9, 8. It's actually directly taken from ISRO. It is a 3D animation of what was actually supposed to happen with Chandrayaan-2, the entire mission. 7, 6, 5, 4, 3, 2, 1. We have ignition. This would be the most important thing. These orbits are all called as transfer orbits. Okay, what happens is you don't push it in the first attempt, or you don't push it in one go. You first slowly start increasing your altitude, you will start increasing your orbit, then finally you will push it onto another orbit. That is also again not the final orbit, it only helps you in moving to the moon. Not just the moon, even when you put a satellite from the earth, you do it in multiple orbits. The orbits in between are all called as transfer orbits only. Okay. After landing on the moon, it has to maintain the line of sight with the Earth. That is very important parameters. That is the reason why they have actually shown that. Okay. Okay, there is one more change here. For the Vikram lander, if you looked into Chandrayaan-2, the Vikram lander was covered with solar panels only on both the sides. But for Chandrayaan-3, what they did is actually they covered the Vikram lander with solar panels on all the 4 sides. So that even if any one side is facing the sun, it will still be able to operate. Okay, so even during night time, even after the period is over, when it is actually exposed to the extreme cold regions of the moon, any one side, if it is still capable of getting in touch with the sunlight, that will still keep the lander operative. That's fine. Okay, right. Okay, so now let's look into Chandrayaan-3. Right, as always, the satellite will always be present in the nose only. There will never be any doubt in that. And this one is what you call as the propulsion system. So this is the propulsion system which will be pushing this Vikram lander into the orbit. Okay, once the lander is put onto the surface of the moon, then from within the lander, the rover Pragna will come out. Okay. So this will this propulsion module will actually take up the role of orbiter for the previous version. Okay. Then because it is GSLV Mk3, which is actually now called as LVM3. Okay. So you know very well the first stage is solid, the second stage is a liquid fuel. The third stage is what we call as a cryogenic fuel. Okay. Along with that, there will be some boosters, add-on boosters. Okay, there will be 2 add-on boosters for this. Actually, for any space vehicle, launch vehicle, boosters will be the first one to fall off. See, add-on boosters, just as the name goes, it is to give it more push, more boost as we call it, so that it will be able to easily lift off into the space, escaping the Earth's attractive velocity or gravitational velocity. Okay, right. Then okay, as far as India goes, the launch pad, any launch of satellite that is taking place from India, it will always be from only one launch pad, which is Sriharikota. Okay, we don't have any other launch pad from where we launch satellites into space except Sriharikota. Okay, as you all know, Sriharikota is present in Andhra Pradesh, right? The area is actually called as Satish Dhawan Space Center. So within Satish Dhawan Space Center, we have Sriharikota, SHAR. Okay. Then South Pole, that is, sorry, South Pole is actually the intended destination. Then the time period will be for one lunar daylight. The name is very specific there, daylight. That's what I was telling you. Okay, 14 days daylight. That time it will be there in there, right? Then it has a propulsion module. It will have a lander and a rover, which will be carried by Mk3. So again, basic details of the mission here. Nothing more than that. Okay. So why is Chandrayaan so important? As we discussed earlier, not just India, other countries are also aiming at this point. Okay. If we succeed in this as of now, we'll be the 4th country in the world to actually have made a soft landing on the moon surface. Okay. Then this will also be the world's first mission into the South Pole. Until now, even now, luckily, again, I don't know if I'm supposed to use the word luckily. Because of COVID, no one actually went for emissions in that last 4 years. So from the last Chandrayaan-2 mission until now, no one has, some countries have actually tried it again, but even they failed. Japan, I believe, had a mission like that. Okay. Right. And like I also said before, most of all the missions until now, they happened just above and below the equator. None of them traveled mid-latitudes also. So now we have actually gone all to the way to one extreme. Okay. So for these reasons, these are all more, I wouldn't probably call it political, but they'll establish ISRO as a soft power more. Okay. Right. Every mission will definitely have what you call as objectives. Why are we doing this? The obvious question. So what are the mission objectives of Chandrayaan-3? All of these objectives, whatever I've taken, they're directly taken from a statement given by ISRO 2019 when they were going for Chandrayaan-2. The objectives have still not changed for Chandrayaan-3 also. Okay. The first one, why we have chosen the moon? Because it's the closest to cosmic body we have. Okay. So if we can understand about the origins of the moon, that will help us understanding the origins of the earth also in turn. Okay. Second one, this is actually very important, what I told before. It's a test bed to demonstrate technologies required for future deep space missions. Okay, this means that any technology we are trying to use for the future. See, understand, India is not going to stop with the moon. We went to Mars, we are not going to stop with Mars. We already have a mission planned to Venus. We already have a mission planned to Sun. And we'll definitely start, at some point of time, we'll start thinking about crossing the solar system also. So when all of these things start happening in the future as a very strong possibilities, any technology we use that will make our job easier, you need to test it first before anywhere. Okay, so this will actually be that. Whatever deep space missions we are planning for the future, Chandrayaan-3 is supposed to be a testing field for all of those technologies. Okay, because after this we'll go for Gaganyaan, which is the most important mission we'll have. After Gaganyaan, we are again going back to Aditya L1, India's first mission to the sun. So automatically we will get all the data we need. Okay. Then stimulate the advancement of technology. It's a very, very obvious reason. When ISRO successfully demonstrates that the technology works properly, more and more people will come forward to adopt the technology, which in turn will make the technology more, usable. When more people start adopting it, there will be more demand, there will be more growth, etc., things like that. Ultimately, that is basically what we want here. Okay. Then promote global alliances. 10 years before, 15 years before, if ISRO would have said we are a good space power, no one would have taken ISRO seriously. In fact, if you look into the last 15 years, NASA has not signed many agreements with ISRO at all. But now NASA is doing it. Why? Because we have very efficiently and capably demonstrated our technical superiority, or our technical capability, if not superiority at least. Okay. So these are what will result in the formation of global alliances. See, global alliance doesn't mean only with NASA. In the future, let's say if any country wants to send their satellite to space, instead of going to some other country, they'll definitely come to India. Countries in Asia, countries in Africa, okay, South American countries, they can all come and take the help of India for space launches. It will boost our revenue, it will improve the relations between the two countries, and yes, foreign exchange also will be taken care of. Okay, and this will actually be a follow-up to Gaganyaan mission also. If you are successful in Gaganyaan, then again, whatever technologies we have used in here, they'll all be helpful there. And if that becomes successful, then people will start sending their astronauts to India, to send the astronauts to space. Okay, so the options are actually, I wouldn't call it limitless, but tremendous. Okay. Then finally, inspire a future generation of explorers and scientists. The last one is very important. Once you do this, the students, the children who are currently there, they will start taking an interest in science. We have the biggest demographic dividend in the country, but unfortunately, we are not able to exploit that one properly. For a lot of different reasons. There is no need of getting into those details right now. Okay. But if we successfully prove these type of missions, then more and more people will start taking interest in looking into this. You know, for this yesterday's launch, there were thousands and thousands of people actually waiting around Sriharikota to look into the launch. Apart from that, millions of people have watched the live on internet, live streaming, which means that people are genuinely now interested in this. So it will give the younger generation hope and a direction to actually move towards these areas. There is a very big need for scientists and resources in this one. Okay. So these are the main intentions as to why we have gone for or why are we going for this Chandrayaan-3. Okay. See, these mission objectives are the latest ones. Apart from that, it's again the usual. Trying to find out the topography of the moon, trying to find out different parameters present inside of the moon. Okay. The atmospheric conditions, the terrain, then the mineral composition, etc. Any new body you're trying to find, you're trying to explore, they will more or less compulsorily be there. Okay. Right. So this is how things will actually happen there. So from this initial orbit, these are all called as transfer orbits. This also is a transfer orbit. Then finally it will be put onto the lunar orbit. Again from there you will again maneuver it, and this green one is the main or is the destination, as we say, the 100-kilometer orbit above the moon surface. Until you put the lander in that particular path, all of them will be considered to be transfer orbits only. This one is more important because you're transferring it from the Earth's orbit to the moon's orbit. Okay. Right. Then this is one thing which people do not probably realize or recognize. Why is it that 2:35 was chosen? Yesterday the launch was supposed to take place at 2:35 p.m. It started exactly at the same time. So why was that specific time chosen? Does it make any difference? What if we are launching at 3:15 or 4 o'clock? Okay. That is basically what we call as a launch window. Launch windows are very, very important when you are going for missions. Okay. So why is launch vehicle or why is the launch window so important? Because first let's look into the definition part. The launch window refers to the time period in which a particular mission must be launched. It's a straightforward sentence. I don't think there should be any confusion in this. Okay. So like I said, it took off at 2:35 p.m. yesterday. What happens if it does not take off at that point? Okay. It's just like, let's say you are going for a 200-meter running race. One lap around the ground. Okay. As soon as the whistle goes, all of you are supposed to start at the same time. What if you have a 4-second delay or a 5-second delay? We all know very well how much 4 or 5 seconds will mean. Because within the 4 or 5 seconds, your opponents would have already taken a lead for you. Which means that you will not reach the destination at the intended time and the intended place. you may end up reaching late, which will ultimately be useless. The reason why we put them at that particular time is that they will go and match with the orbits that are actually supposed to be there. Okay, if you look into the earlier picture, I told you there is a intermediate orbit. The one that is actually taking it from the Earth's orbit to the Moon's orbit, that trajectory. Okay, if that trajectory is not happening at the right time, you will actually put it on the lunar orbit in a long orbit, which means that you will not be able to push the satellite from the Earth to the Moon so easily. Simple. Either it will get delayed or you'll have to wait for some time again for waiting. See, it's not like you're driving a car on the road. Okay, petrol is about to get completed. Let me go and fill the petrol and again start coming in. When you're in space, you can't afford all of these things. Right? So if you don't put it in the right timing, it will not overlap with the orbits of the body to which you are planning to send it. In this case, it is a moon. There should definitely be an overlap between the moon's orbit and the satellite's orbit. Then only you can actually push it onto the moon's orbit. Otherwise, you can't do that. Okay. And the second thing, this one. They'll calculate the shortest and the most fuel efficient path. Fuel efficient, please keep it in mind. I told you, because whatever fuel you put in there, that's it. That will be the one that will be there. You can't get any extra fuel if you want somewhere. Unfortunately, there are no provisions like that in space. Right? So this launch window will be kept in mind based upon this criteria also. So that you will actually push it in the right time and in the shortest path. If you push it in the shortest path, you'll be able to reach there faster. As simple as that. Otherwise, why do you think these people are saying it will take 40 days or 42 days approximately to reach to the moon surface? How did they know? What basis did they calculate that this time period? It comes here. Okay. And finally, this one. When the rover is actually being put on the surface of the moon, it has to be during the beginning of the lunar light day or lunar sunlight day. If it is not beginning in that period, you will have to stop the rover for 14 days. Actually, you'll have to stop it for 28 days, because after 14 days, you'll have night coming in on the moon for another 14 days. So once the 28 days are over, then again you start with your sunlight day. Sunlight lunar day. Okay, so imagine what happens if you are supposed to delay it by 28 days. After that, you don't even know if any of those things will respond or not also. Okay, that is also the reason. Because of this time off, and because if everything functions according to that time, the time for which the launch window has been selected, you will put the rover at the right time on the surface of the moon and it will start doing its job immediately without any delays. Okay? Right. And these are all the payloads that are present on the moon on Chandrayaan-3. Okay. The payloads are more or less similar to what have been there for the last time. They've added some 2 extra payloads. Okay. So there will be payloads on 3. There will be a payload on the propulsion module. There will be a payload in the rover. There will also be payloads on the lander. Okay. So the name and the function has been given in there. The ones which are present on the rover, automatically they will try to go for the elemental composition of the moon along with what is the site where the landing has taken place. Okay. So basically it will get a picture of the site around where the rover is supposed to be moving. Along with that, when the rover starts moving, it will start collecting samples, analyzing them, then sending it back to the base station in Bailalu. Okay. Remember, whatever data comes from this Chandrayaan mission will go to Bailalu directly. From there, it will be sent to ISRO, Mission Control Center, MCC. Okay. Then, the ones which are the payloads which are present in the propulsion module. Propulsion module will still be there around the moon. Please keep it in mind. Okay, the propulsion module is supposed to be there for 6 months. That is the ideal time period. It may be for less, it may be for more. We can never assure that part. Okay. So this payload is supposed to look into the spectral and polaric measures. Basically, it will start looking at different spectrum wavelengths from the moon onto the Earth. So from the moon, is there anything else you can see of the Earth? Something which you cannot see when you are present within the Earth. Okay, it may look silly, but it's not. Please believe me in that. Spectral compositions will be different when you are at different distances, when you are under different conditions, and when you are exposed to different atmospheric variations. Okay. Then finally, the one which is present in the lander. The lander will try to look into thermal conductivity and temperature. Thermal conductivity is basically, if at all any thermal conductivity is found to be present in there, that gives a slight indication as to some materials or some minerals that are actually good for that one. Okay. Temperature variations. This is always very important because you need to know how, what kind of instruments you're supposed to build that can withstand extreme low temperatures if need be in the future. Okay. Then you're also trying to measure the lunar seismic activity, or what we popularly call as the lunar earthquakes. You know, there are a lot of earthquakes that actually happen on the moon also. Like I said, it has the same compositional elements as that of the Earth. Okay. So they'll try to measure the activity around the landing site only. See, all of this data can be given only because the lander is there. So around the lander, whatever area it can cover, it will try to do that. Okay. Then finally, there is one more one, plasma density. You know what is plasma? Plasma is considered to be the fourth state of matter, apart from solid, liquid and gas. So ideally, plasma is also gas, but which has ions in it. Okay. So there is plasma present on the moon also, because that plasma gets exploited by the moon, which is coming from the sun actually. Sun is completely made up of this plasmic material only. Okay. So there is plasma density present on the moon also. So what is the property of it? To what extent do we have it? Can it be advantageous to us in the future? Can it be disadvantageous? We are starting to understand all of those criteria also in there. Okay. Then finally, there is one more payload which belongs to NASA. Okay. That is for what we call as lunar laser ranging. We are basically using laser light for measuring certain features in there. Okay. So that one will be anyway manipulated by NASA directly. The rest of the payloads all will be looked into by ISRO. Okay. Right. When it comes to payload, you need to know what does what and all of that. Okay. Then the term which I was trying to tell you before, space race. Space race is when you're trying to put different missions into the space competing. This one is the moon race. See, you know very well, US was the first country to actually put a person on the moon. 60s, 70s, Apollo mission, the broad name given. After that, for 50 years, US never attempted again to put someone onto the moon. Now, there is another mission, Artemis. Artemis is again US mission to put people back on the moon. Okay. And there are many other countries in the world also who are trying to explore moon right now. Not just India. So the automatic question comes, why are so many people trying to race to the moon right now? Why do you think we chose the solar one? Because one thing, and the most important thing, I think, we'll be the first country to do that. So we'll get a lot of exclusive data if we can, which until now no other country would have access to. Okay. No one will talk about those kind of objectives, but Any mission, they'll definitely be there. Okay. So the first thing is they're trying to create a permanent presence in there. Maybe they want to build a space station on the moon itself, countries. There is a very strong plan in many of them, especially US and China. India also has an idea regarding it. Okay. They want to keep a complete presence, and like I explained to you before, pit stop for the future. Any missions where you need to move out of the earth, instead of starting it from the earth, you'll start it from the moon itself. That is one of the reasons why we are so concerned about water. Otherwise, if water is not there on the moon, we'll have to carry gallons and gallons of water from the earth. It will again increase the load of the aircraft. That will again compromise other features. Okay. And finally, to understand the moon properly and to know what are the mineral contents present inside. Maybe those were the minerals which were there in the beginning of our planet also, before we started exploiting them. Okay. Right. So these are the other missions which are supposed to be there in this very same year. Okay, this one is ours, which already started recently. Then US also has some missions to go for. Then Russia also has one, and South Korea also has. Apart from this, China is also, Japan is also trying. Okay. There is one mission of European Union also. May not be this year, but yeah, within the next 2-3 years. So there are many countries forward who are trying to put missions to the moon again. That's the reason why we are calling it a moon race. Okay. Right. So this is why Chandrayaan-3 has become very important for India. It is not only a boost for our morale, it will also be a technological demonstrator of India's capability. The biggest achievement will actually be that one. And India is very well known to make all of these missions at a very low cost. Okay. It will in turn boost our revenue, etc. Anywhere you look, it's always advantageous only. Right. So this is what you need to know everything about Chandrayaan-3 mission. I hope this was helpful. Thank you.